conversation. There is also a reason the cupcakes up there. Yeah, we usually do cookie exchanges in the class. Like somebody brings like a healthy homemade treat in this class, but these guys have very aromatic smells, as we'll see as we're going through this. So be careful, it's a cyclo, so cyclopentane. Now, the carbon in this case, the double bonded O is at number 1, just because it's a cyclo. It's that this carbon that the ketone is attached to is a secondary carbon, meaning that this carbon is always attached to 2 carbons. Wow. Aldehyde is always a primary carbon. The carbon is only attached to 1 other carbon. So again, this is a secondary carbon, like with a secondary alcohol. So isobutyl 1, 2, 3. There's my, and isobutyl is the P sign with an elbow. All right, those are all single bonds except there. 3-pentan L. And your double bonded O, it doesn't matter which end you put it at, and at 3 you'll have an ethyl. So again, that's 1, 2, 3, 4, 5. And then diethyl ketone. What this means is you have the ketone. It's kind of similar like an ether. You put the ketone, and then you put an ethyl on each side. So the actual name for this, the IUPAC name would be 3-pentanone. They used to all be named like this until they went with the systematic thing. So diethyl ketone is the same as 3-pentanone. So you draw the ketone carbon and then 1 on each side. So unlike an ether, where the ether you can't number all the way across the oxygen, here you do because the oxygen's is attached to the longest chain. All right, and then these we're going to name. So this is 1, that's our aldehyde. That's 2, we have a methyl there, 3, 4, 5, 6. So hexanyl. You do want the AN to show it's saturated, and then AL, and then we have methyls at 2 and 4. So 2,4-dimethyl. You know, this is kind of meditative. You know, people buy those coloring books to do coloring like the mandalas and stuff. That's what kind of the naming becomes. So approach it that way. All right, 1, 2, 3. So it was a question that came up during office hours. Alcohols, the OH does not have to be at number 1. And same thing here. In fact, with the ketone, it won't be. So 1, 2, 3, this is 4, 5, 6, 7. And then this is saying we have a CH3 on each side of that. So 7, 8, 9. So this is a methyl, there's a methyl, there's a methyl. So we got a bunch of methyls. So 4, 7, 9. I'm sorry, 4, 7, 8 trimethyl. Oh, I love this one. 3 nonenone. That's like you could do if you do drumming, 3 nonenone. So 4, 7, 8 trimethyl 3 nonenone. So the AN is that it's saturated, and then the one is the ketone, and the none is 9 carbons. All right. This is a side group. We are going to start numbering from there. So 1, 2. You number from where the double bonded oxygen has the lowest number possible. So kind of like with the alcohol, or it is like with the alcohols, and then 3, 4. So that's a side group. So the methyl comes first alphabetically. So 3 methyl, and then 1 phenyl. And then 4 is butanone. So here you go. I need somebody else on the board. I didn't put a number with butanone. Why don't I put the 2?
Because there's nowhere else for it to go.
Exactly. On a butane, on propanone and butanone, it is always at number 2. So here's another question. Could you have an ethanone? The answer is no. Because if there's only 2 carbons, then the double bonded O is always at number 1, which makes it ethanol. So it makes it an aldehyde. Was there any questions on any of those? All right, acetone is the common name. These are some famous or common ones. You've all heard of acetone. It's in fingernail polish remover. In lab, this is what we use. It's like the common solvent. It dissolves everything. So if we're in lab and you can't get it, you can't clean your test tube, you're like, hey, Sherpa, can I have the acetone? And we add a little bit of acetone, especially if we don't know what was in there. And the acetone will dissolve polar and nonpolar. So meaning polar and nonpolar. And the reason is acetone is 3 carbons. So it is 1, 2, 3, and double bonded O is in the middle. So CH3 on each side, or with the zigzags. That's what it would look like. So we have a small carbon chain. So nonpolar things will be attracted to, and we have the oxygen. So it dissolves polar things. I mentioned the other day, diethyl ether traditionally is done for that too, because it has the carbons and it has the oxygen in the middle. The advantage of the acetone is it's not going to be explosive. Disadvantage is it does have a strong smell. I'm pretty sure most of you know the smell of acetone. Formaldehyde. So the prefix form means 1 carbon. And it actually means ant, not like anti-mill. It means A-N-T, ant. So like the little ants that right now, it's too cold for them to be in my kitchen, but they are a blessing whenever you see them in your kitchen, because it means there's not going to be an earthquake. So the ants go away a week before an earthquake. It's actually the best way to predict an earthquake. 100% perfect. Animals always know when the Earth's about to shift. The only animal who doesn't is, for some reason, us. So if you squish ants, apparently they don't produce formaldehyde. They release formic acid, which is a 1 carbon acid. We'll see it in 2 weeks when we do carboxylic acids. So formaldehyde is the simplest. The other name for formaldehyde would be methanol. That would be the IUPAC name. Nobody calls it methanol except an introductory student. The thing that's so special about this, it's going to have 2 hydrogens, 1 on each side. So the formula is just CH2O. Formaldehyde is what they use to to preserve livers or bodies or something like that. All right, MEK. Does anybody know what MEK stands for? Melanie's not here. She probably would have known.
Methyl, ethyl, and ketone.
Yes. Is that Vincent? It sounded like
Yep. Yeah.
So methyl ethyl ketone. So this is the same as butanone. I'll draw it up above. So you'd have the ketone. So we'd say this carbon, and on one side you have a methyl, and on the other side, did I do that right? No, I of course didn't. Sorry. So there's my carbon, that is my ketone, and on one side you have the methyl, and one side you have an ethyl. It was also a universal solvent because it's a little bit more carbon, so it's really good at dissolving nonpolar, but it's not too long in that oxygen. It's even better than acetone. It also pickles your liver super fast, even better than these other ones. All of these are extremely not good things to work with as far as toxicity. If you want to like do your presentation and paper for the end of the term on like a real downer, you could pick methyl ethyl ketone. I'm not sure if you can get it at Home Depot anymore. You used to be able to, but and it's used, actually was used like by the Air Force. I had students who'd been in the Air Force because it's what they use to clean a lot of stuff because it's so good at dissolving everything. All right, benzaldehyde is the smell of almonds. So we go from really noxious ones that are going to cause issues to your liver to something that smells like almonds. And that is, so benzaldehyde, you cannot have the double bond on the benzene ring. Why can you not have it on the benzene ring?
Too many bonds?
There would be too many bonds, right? So this, if I drew it the other way, that was Emma. Was that you, Emma, who said that? I think so, because your thing's lit up. This carbon already has 1, 2, 3 bonds. So if we try to do a double bond right on there, it can't happen. So you have an elbow, and then the oxygen is attached to it. So there's one carbon attached to there. Another way that you actually will usually see benzaldehyde drawn is they'll put a line and then they'll write the CHO, saying the same thing. As you get more carbons, so remember I said that cupcakes are there because these guys are really nice smelling, not when they're small. The small ones, for some reason, whatever they interact with, the smell buds, we don't have taste, we have taste buds, I don't know what the smell ones are, but the smell buds, when they're small, they interact with ones that say, oh, this is bad, toxins, stay away. But as they get larger, they actually have a very aromatic and flavorful. So benzophenone is geraniums, the smell of geraniums. And in the essential oil for geraniums, this is the molecule. And that's the common name. We're going to do, well, that's the name that it gets. It's a diphenyl, could also be diphenyl ketone.
You use it?
So we're saying this is my ketone and I have a phenyl on each side. So again, as they get larger, this one, again, if you want, like, if you're addicted to microwave popcorn or movie theater popcorn, maybe you should do this molecule and that will help. So 1, 2, because it is extremely toxic. Again, it's a small one. And so it's, I think it's usually butadiene. I don't know if it's butanedione, which would make sense. I think it should be butanedione. Why do you think it should be butanedione? Why does your teacher think that? The dye is telling you there's
The
two
double
ones.
oxygens.
The dye is for the double oxygens, but the reason I erased and wanted the whole ane there was to indicate the carbons are all single bonded. The one is the double bonds to the oxygen, but that's actually the smell and the flavor. It's actually the smell. So 75% of taste is smell. It's actually a game I'm playing with my kids that I do. If you put vanilla extract, just like spray it on a handkerchief or whatever, and put it over somebody's nose, they're smelling that, and then give them something else to eat, they think it's vanilla ice cream no matter what you give them. So you give them a radish, and so they're smelling the vanilla and they're not smelling the radish. They don't know it's a radish. You can have them plug their nose and give them like a Granny Smith apple versus another apple, and see if they can tell the difference. You can do it with candy too. Have them close their nose, blindfold them, and see if they can distinguish different candies, like a Mike and Ike pack that will have 4 different flavors, and you can't. So those of you who have little kids, have younger kids. So like Maze, you can play this with him, Christy. So there's all these different things. We usually actually do a lab on smell. I don't get to do any of this stuff with you all. But so if that's one of the big things with COVID. So it's actually they're losing, when we lose our sense of smell, because we're all clogged up, that they lose the ability to taste. All right, and then the last one, number one has to be at the aldehyde. That takes preference. It gets number one. I know that double bond's there, and I said that earlier, but this is now our preference. And then 2, 3, 4, 5, 6, 7, 8. So that's why here I had to make sure the ane was there. So heptene, oh wow, it's not hept, it's oct. So oct for 8, but octene, En, and then Al. So the aldehyde, we do need to put the double bond is at 6. So this 6 refers to the En. And then we have some methyls. So at number 7 and number 3. So 3,7 dimethyl. How this is drawn is actually beautiful because they do bend around like that. Questions on this first page. And that one is Citronella, which is the smell that people will burn the Citronella candles to keep mosquitoes away. Like those little tiki torches, they'll put Citronella in them when they're having a barbecue to keep all the mosquitoes away in the summer. And so the smells, I think it's kind of pleasant, but mosquitoes cannot stand the smell of it. The best way to keep mosquitoes away is eat garlic. They don't like the smell. So we give off some kind of aroma, apparently, when we eat garlic. Some of you might be saying, yeah, people definitely do. And mosquitoes will not come near you. All right. If you eat healthy, they don't seem to come either. I think it's that people eat a lot of meat. They must give off a certain aroma. And I know when you're vegetarian, they don't seem to go after vegetarians as much. The other trick with mosquitoes is just have a kid with you because they love kids. And so, all right, reactions. It's the year of the redox. Tomorrow. I lost my redox. So there we go. Red is here tonight. He's a little bit too big. I'll just hold him. There, you can see him. And we're going to do oxidation reduction. So we're going to review Leo, Gur. So it's the year of the metal ox. And it's perfect for a chemist. 2021, starting tomorrow. The year of the rat is almost done. Leo is losing electrons is oxidation. Oops, losing electrons is oxidation. So I went through this. There is, and Gur is gaining electrons. I should have done this in 2 different colors. Gaining electrons is reduction. This, I actually just did this also. I'm doing this with all 3 of my classes. That's ironic since we're right in the year of the redox. So organic chemistry, what is the definition? Instead of saying losing electrons, what do we look for? And there's 2 things to get the point. I have both things. Even one thing? Hydrogen. So when you lose electrons, you lose hydrogen. When you gain electrons, you gain hydrogen. When we did this with the alcohols, we did oxidation. There's an or. So you're either going to lose electrons and hydrogen, or the true term for oxidation, why it was called oxidation, is that you gain an oxygen. That's all they gain is oxygen, nothing else. Reduction, they lose oxygen. That's why it was called reduce, because they actually lose an oxygen. This is actually the definition before electrons were discovered. They didn't know anything about electrons yet. And they just were doing biochemical reactions and noticing oxygen's gaining, losing, and they came up with this term, and then we expanded it over time. So we're going to do oxidation first. So this is an aldehyde. Let's redraw it with the double bonded O. And it's going to gain an oxygen. It works because of that hydrogen there. So you're still, the carbons do not change. The oxygen already lost its hydrogen. So what happens is we pick up an oxygen. An oxygen scrunches in there. It pushes the H over, and it's the attraction of this oxygen, and we move it there. Now, if you try to do that with propanone, there's no place to add another oxygen. There's too many bonds, so no oxidation. Ketones, no oxidation. Aldehydes, they may know what this functional group is and want to take a gander at what the name of this might be. Prop, ane, oic acid. So we say oic and acid. It's a carboxylic acid, so like fatty acids. And we get there in 2 weeks after the celebration. We'll talk about fatty acids. So that's one of the things that's nice is we see where we're going on the next one. Ketones do not oxidize. Tertiary alcohols, remember, did not oxidize. All right, so reduction is the opposite. So we're going to add hydrogens. So butanone somebody's not muted. I like the music though. Maybe we should just keep it. So butanone, you're going to add hydrogens at the double bond, and you're going to end up with an OH. The other H would be here. I'm going to show it on this one just because I'm showing you the first time. So you're adding these H's, and the nickel is a catalyst. Without the catalyst, nothing happens. So the catalyst itself is not involved, but without it, nothing happens. So we go from a ketone, goes to a secondary alcohol. So that's when you add hydrogens. So that's reduction. I don't know if you remember, but we did secondary alcohol to a ketone was we lost hydrogens or we went through oxidation. So all we're doing is undoing the reactions we did last Wednesday. All right, if you have an aldehyde, again, you can redraw this so you see the double bonded O, and our reaction, we just have 3, we have an OH. So this was 3 carbons. And again, the H would be here and on there. So an aldehyde will go to a primary alcohol. So if you add hydrogens, which is again reduced, you go to a primary alcohol. If you had a primary alcohol and you lose hydrogens, that's oxidized. We're going to take this one more step. The aldehyde can keep being oxidized. I don't know why I'm writing backwards. And go to a carboxylic acid. And again, next week we'll go through all of these again, but aldehyde can be oxidized and reduced. Ketone can only go through reduction. These guys do have other reactions, but we're not going to worry about them. If you take biochemistry with me, we can do it then. All right, properties. So alkanes versus an aldehyde or ketone, which one's going to be higher and why? The aldehyde or ketone is higher. You know what? So yeah, the aldehyde ketone is higher than an alkane. And that is because the alkane is nonpolar, and these guys have the oxygen, so they are polar. But the alcohol is the highest because of the H bond. All right, solubility, you all know the answer. Anybody want to share? So yes to a point, meaning that the number of carbons. So yes, because it's polar, you have the oxygen, water loves the oxygen, but if you get too many carbons, so we'll write that, too many carbons, and the aroma, small ones stink. I mean, I don't know what the smell of formaldehyde or fingernail polish remover, what you want to say that smell. The small ones are stinky, like formaldehyde and acetone. The larger ones are aromatic, meaning more carbons. And that the examples were on the other side. Cinnamon is an aldehyde and vanilla is an aldehyde. So that might be some examples. So vanilla, cinnamon, almonds. Anyway, not all the really good smelling stuff is aldehydes and ketones. There's going to be another family that's even better smelling. All right, this last point is a big point, Tollens test. And I do this in the video for next week's lab. And then I meant to bring it home to show today if I make it to lab and get my example. But Tollens test is also known as the silver mirror test. And so this is actually one of my big bummers that you're not in lab, because this is a really fun test to do. And it's actually really funny in the video because I was like, well, I'm going to give myself the same advice I give to my students, which is just keep going until, you know, because it says keep adding until this happens. And they're always like, I'm at 50 drops. And I was in the video. And so I just kept adding. But it's a silver mirror test. And that's what you get. You form a silver mirror. Only aldehydes do this. It is the test for an aldehyde. It's not a simple test, but it's not an impossible test. Like, you guys can do it. I've done it with the kids. And once you get it to a certain pH, you just sit there and everything else just looks like mud. And it starts forming a silver coating on glass. And it just has to do with you have silver. What's happening is you have silver ion becomes silver solid, which is the metal, and that's the mirror. And so the silver, what's happening to the silver here? Remember, silver by itself gets the halo. So it's going from a +1 charge to a 0, which means the silver is gaining an electron. So the silver gains an electron. So it's reduced, and who it steals an electron from is it gains an electron from the aldehyde. And it is because an aldehyde is the easiest thing to oxidize. Nothing else will do this. Alcohols will not. But it's so easy to steal electrons from an aldehyde that something as simple as a silver ion can do it. So easy to steal electrons from. And it has to do with that position of the oxygen on that first carbon with the hydrogen. It just makes it really easy. All right, any questions? Not, keep moving on, almost done. All right, so our new game again, ID functional groups. This page is here because again, you're going to pick an organic molecule. I'll get more persistent next week and the week after. Because I'm just trying to give you ideas. There are so many possibilities. And so the terpenoids are famous these days because that's what the CBDs are. And so a terpenoid is actually, has to do with the shape and then different things. The ring closes. So that's where the terpenoid part comes from. I think I talked about CBDs and stuff back when we did alkenes. We saw pictures like this. But functional group, we have alcohols. That's a phenol, right? This is a benzene ring. Do that in pink. If I asked you to classify the alcohol, this is menthol as in mint. It's actually kind of cool because it's different isomers. That would be a secondary alcohol. So again, this carbon that the OH is attached to two others. This one up here, that's a tertiary alcohol. So that is a methyl group going behind there. All right, the other reason I wanted to show these is because you may pick a molecule and you're going to start seeing some really funky. This is like a double ring. So you see this oxygen, it's attached to this carbon down here and this carbon over here. So this is actually an ether. That is eucalyptal oil, which is actually really cool. When you pick yours, you also have to find 2 studies about it. So, which you should be able to on the internet, no problem. And then this one, camphor, which is used in India to get rid of evil spirits. We usually make camphor in lab, so very sad because it's a fun lab. And that's a ketone. See the double bonded O. This is morphine. It's quite an interesting molecule because see how it has this extra ring, and they show it all different ways, but I've had several people do really fun, not fun, but fascinating papers. So hospice loves morphine for alleviating pain. So secondary alcohol, it binds to our endorphin receptors. So morphine comes from the poppy plant. It's extremely addictive. This up here is a phenol because it's on the benzene ring, whereas this is a secondary alcohol because that's not a benzene ring. And then this guy here is an ether because it's an oxygen in the middle. Anyway, so I've had people actually do heroin, and it was actually, they found some really interesting, fascinating studies. Or you can pick, I'm sorry, oh, here we go, resveratrol. So from grapes, so resveratrol is the one that is the red grape. It's the polyphenol. So this is a polyphenol. You can, if you identify, it's called a polyphenol because there's 1, 2, 3 phenols. And so it's a super antioxidant. The polyphenols are super antioxidants. I don't fully know why. It must have something to do with when you get that multiple OHs on the benzene, it's just going to do its thing. And then these are all polyphenols down here, as well as there. So they're just benzene rings with bunches of OHs on them. So you have flavonoids. So you cannot do your topic on polyphenols, but you can pick a specific polyphenol. So like resveratrol, the anthocyanidins, you again would pick a specific one. In the video I made with the Sherpa New Year and with the dyes you're going to extract, you can pick, well, we talked about the spices in the last one. And actually each one I talk about more. You can also pick, like if you're like, well, morphine and talking about addiction, and there are good uses for it. There's also endorphins, which is the natural molecule in our body. So morphine was discovered, and then they found the receptor for morphine. And when they found the receptor for morphine, they said, why does our body have a receptor for a drug? And they said, oh my gosh, we must already have a molecule in us that does this. That's a natural painkiller, because morphine is a painkiller from nature, from the poppy plant. And so then the search was on, and they found the endorphins, which are a little polypeptide in our brain that we make. And yeah, so pick more uplifting. So different hormones. There's some topics that I'm like, no, that's too big of a topic. But questions with that page, probably on the next study set. All right. So last page, going to give you guys a 7-minute break. You can try it. You can take a break. Go ahead and try it. I'm going to pause if I know how. So aldehyde, 1, 2, 3, 4. It's our last page. So butanol. So you want the butane, AN, and then just AL. We don't put a number. The aldehyde has to be at number 1. That is a set rule. The ketone does not. And so we want our longest chain. The ketone, you want it to be the lowest number possible. So we're going to start here. 1, 2, 3, 4, 5, 6, 7. We're going to have methyls, 8, 9, 10. So if you run into something that has more than 10, I mean, there obviously is a name, but in our class, it would be that your teacher probably messed up. I try not to, though. 4, 7. Or it could mean that you counted wrong. So that's why I will be on Zoom next week while you're taking your celebration. So 4,7-dimethyl, and then we do have to put a number, 5-decanone. That's a wonderful name. It's like decadent. All right, and then the next one, the aldehyde has to be number 1, and then we have 2, 3, and then 4, 5. And so pentene, and then AL. So the EN tells us we have a double bond. We have to put a 2 there. And there's one more word I had to put at the very beginning, which is trans. Because the H's are in that opposite way. Did that happen? I just realized, you know, when we did this one way back here on the very first page, the citronella, that is actually a trans also. No, it's not. Never mind. It's neither. It's neither, because at the 7, it's a methyl on each side. One of them's a methyl, one of them, but so it's neither. All right. Cyclohexanone. So just be careful. It is going to be a hexagon. This is a case where the double bond, the ketone, it is at number 1. I'm going to count the other way. 1, 2, 3. And then at number 3 is the BR. It's just the BR. And on this one, it's pentanol. So wherever you put the double bonded O, that's 1. So at 2, I put a chlorine. And then at 3, I put a methyl above and below. And again, you can draw carbons. I've just been noticing, it seems like most people do zigzags. So, all right, in each of these, we're going to higher boiling point, and then we're going to explain. So they're both ones. I always start by looking for H bond, but they're both ketones. so more carbons. And I'm just going to add extra. They're both ketones. More for you all for your notes. All right, on B, we're going to pick the hexanol because of the H bond. So aldehydes and ketones are polar, so they're going to be in that middle group, but they don't H bond. And then how about the last one? Which one and why? Anybody? The aldehyde, because it's polar. So benzene is nonpolar. So if you have, as a note, the nonpolar are only carbons and hydrogens. They're always at the bottom. So benzene is nonpolar. So the benzaldehyde wins because it's polar. It doesn't H bond, so don't say H bond. All right, a simple test. So we didn't learn about benzoic acid, but I'm pretty sure somebody could tell me a test you could do for it, which if it's an acid, it's going to turn litmus pink. All you want to do, litmus pink. For the aldehyde, the key test for an aldehyde is you can either say Tollens or silver mirror. So Tollens, which is the silver mirror, is what we're looking at. Cyclohexanol, we're going to oxidize. And anybody remember the last one? The ene? This one's really cool when I show it in the video. I got really geeky in it because the color disappears. Like, I was like, did I add it? I thought I like had got it all over the side of the test tube because I'm trying to videotape and trying to hold 3 things at once, and it was not going well. But it was, because as soon as it touches it, there's no color. It's not like it has to disperse in there. It's just like it's gone. It reacts immediately. So you add bromine and the color disappears. So, or it turns clear. Bromine's an orange color. All right, hopefully I'm still there. My thing keeps telling me my Wi-Fi is funky tonight. Complete the reaction. So pentanal, however you like, you can draw your O on the other side. There's a reason I keep doing this. It's a habit. You can draw carbons. Oxidize is the double bonded O is still there, and you pick up an OH. So we pick up an oxygen. This is going to be pentanoic acid. So oxidation of an aldehyde, you go all the way to the acid, and then this is reduction. And we just go to the OH, so we go to 1-pentanol. So we're adding hydrogens. All right, and then the second one for the cyclopentanone, and if it's easier, yeah, we'll just leave it at that. Oxidize is no reaction. Can't happen. If you try to do something, it just doesn't work. There's no room for it to be oxidized. There's no room to add an oxygen, and there's no hydrogen to take away. But on the second reaction, adding the hydrogens, we go to OH, so we pick up the hydrogen there, and there'd be an H there, so cyclopentanol. And that's it. Questions? All right, I'm going to stop.